Good morning. Most of you have just finished suffering through the file IO and 1D dynamic arrays homework assignment. All right, I'm going to make a few video tutorials here to go over a possible way to solve this problem. All right, so to refresh your memory then, right, as you watch this video on what the assignment was all about, right, here's our problem statement. And this is following a homework assignment where we've already done a frequency count. So we're going to use some of that same knowledge that we gained from the last homework on this one. So we're going to create a program that displays frequency and statistical information for a data set. Right? The format of the output should closely resemble this. And it tells you, of course, your output is going to be dependent on your data set. Right, so we've got some frequency data here, and we can see that we have some groups, right? We see 0 to 19, 20 to 39, we have a count, and then we have something called a histogram printing a bunch of asterisks. Right, down below we have the mean, standard deviation, and median. And this figure tells us that there's something called a group size. So our group size of 20, right? We can see that those numbers differ in width by 20, asterisk per count. Well, we don't quite know what that means yet. We need to read on. Right? You need to read this document multiple times, right? Like any problem when you solve it, you go back and reread. All right, our input, our data sets are going to be read from files, right? The program is to ask the user to input the data file name. All right, we're going to open the data set. We're going to open the file for reading. We're going to, and then read the following information from the file. So we're going to read group size, asterisk per count, total number of elements in the data set, and the data set contents. We're told that all numbers in the file are integers. And then we're also showed what the input file format will look like. On line 1 will be the group size value, line 2, asterisk per count value, line 3, the total number of elements in the data set, right? And line 4, lines 4 until the end of data, right? Data values, and those data values we're told are guaranteed to be in the range of 0 to 255. We're told that we may assume that group size, asterisk per count, total number of elements in the data set will all be positive, non-zero integers. Right? That means we don't have to error check for that. We can if we want to, but you don't have to given this assumption. Right? You're given a couple of different data sets to work with this to aid in testing your solution. Right? But we're going to start with a very small data set. As it's recommended here, it's recommended we create our own input file. We use a simple data set to test the accuracy of our solution. Once we do that, we move on to a larger data set. Right, there's our input, right? Our process, well, frequency count of the values of the data set, right? Frequency count is the total count of the number of zeros, 1, 2s, 3s, 8s, 9s, well, all the way up to 255. That was a typo, right? That should have gone through 255. I should really correct that right now. I'm kind of surprised no one asked about this, but so that should be 254s, 255s. All right. All right, and we're going to calculate the mean, standard deviation, and median values. Right. Output should be written both to a text file on the screen and tells us what the extension should be on the text file. And we're going to write the same, we're going to use the same function to write to the file and the screen. We're going to use an OStream parameter to direct the output. All right, now this starts talking about the frequency data output and the groups that we saw above. So the group size variable controls the output group count. Right, figure 1, we showed the group size of 20, and that result in groups in the range of 0 to 19, 20 to 39, and so on, all the way up until this last group, right, which was not 20 wide because we have 256 unique numbers, 0 to 255, not evenly divisible by 20. So this says, note the last group contains the remaining values, 240 to 255. And then it tells us that the frequency data count column column output is the sum of the frequency count for the numbers in that group. For example, like in figure 1, the count value of 192 is for the group 0 to 19. So that counts the numbers, right? So we're going to perform a count, right? We've done a frequency count before. So we're going to perform a count of all the 0s, 1s, 2s, 3s, 9s, all the way up to 255s. And then we're going to go through that frequency count array and count how many fall in this range 0 to 19. And we'll print out that information. That's what this is doing here. This counted then how many numbers fall in the range 0 to 19, printed that out. How many numbers fall in the ranges 20 to 39, print that out. So we do that for each group. Right? That's telling us what to do with the groups. Right? And then the histogram output depicts the frequency data count. It uses a variable asterisk per count to determine the number of asterisks to print. So this first group, right, has a count of 192. The asterisks per count are 3. So each asterisk represents a count value of 3. So for every one of these asterisks that are printed on the screen, that should represent a count value of 3. So if we take 192 divided by 3, we have 64. And that should be the number of asterisks we want to print. So for this example, there should be 64 asterisks here, right? So asterisk per count 3. 3 times 64, right, won't be quite 192, because if it's not evenly divisible, we lose what's in the remainder, right? This is where this tells you this. We can't print partial asterisks, so we're not going to print an asterisk for any remainder values. If we look at the numbers in figure 1 in the range 20 to 39, the count of 190 is not evenly divisible by 3, right? It's 63 and 1/3, so only 63 asterisks are printed. So if we go back up to this figure, you can see that 1 asterisk less is printed for 190 than 192, right? So we're just going to truncate and use the integer value to print our asterisk. And so here's another example down here, right, of this visualization, this histogram visualization, right? So the group size here was 15, so we can see our ranges are in 15. Our asterisks per count were 5. So 139 divided by 5, right, we'll have a remainder of 4. We'll truncate that. Right. Same way here, we'll take 141 divided by 5. Notice that 140 is evenly divisible. So we're going to have one more asterisk for 141. Right? And we'll still have a remainder of 1 where we truncate there. So the asterisk per count then is going to determine how many asterisks are printed. That's all based on this count, and this count is based on the group size. So we've thrown a little bit of complexity into there. Right? You're also going to calculate the mean, standard deviation, and median. Round those to 1 decimal place. Right? This tells you then how to perform those calculations. I won't go through that right now. This reminds you of the frequency count. This also tells you you should have multiple functions and other files, right? We don't want to write all our code in main. We're also told about error checking, memory allocation, and deallocation. Not to use global variables. We're also asked to use a global structure to store in our stats, so we're going to declare that globally. We have a lot going on in this problem, right? This requires reading multiple times. It requires reading, making some notes, starting to solve the problem before you start to write any code, right? Read it, write some notes, put it away, think about it, come back to it later. Come up with a problem-solving methodology. Come up with a way to break this down into more simple code. Right. All right. So what I've done is, right, I've created an empty project here. I posted a discussion forum on how to break down the problem. Let's see if I can pop that open in Canvas. Right here, I asked you what your plan was, right? Like I said, we don't sit down and write code without a plan, right? There's lots of ways to solve the problem. You need to start creating an outline, right? As you create your outline, it's not really important that everything initially be in order. Just start jotting down your thoughts and then you can start to put your thoughts into order. So I came up with my high level sort of pseudocode for this, which I'm going to copy paste into here. So I'm going to create a main.cpp file. So I'm going to add a new item, C++ file. And all right. So that didn't translate quite as well as I would have liked it, right? Because this is a text file, we can't do the special characters. All right. So we started breaking down the problem by saying we want to get the input name from the user, right? So input file name, we're going to open the output file, we're going to read the data file. So let's separate this out. So here's what we're going to read. I'm going to separate it out that. All right, so we're going to read the data file, and we're going to read group size, asterisk count, array size. This says now that the array size is known, we can create the file data array, and we can read and store that here. So we're going to create, we're going to read and store, we're going to process, we're going to calculate. All right. So we're going to create the data file away. We're going to read and store the array data from the file and store it in the file data array. That's a little bit redundant. All right. We're going to process the data to find the mean, median, and frequency count, right? We're going to calculate the standard deviation. That's dependent on the mean value. And then we're also going to calculate the frequency count, right? So in order to do the frequency count, right, we need to create an array to store that. That array size is based on the unique values in the array. We list the unique values. We're going to initialize that. Right, we're going to read through the file data array created above, counting the zeros, ones, so on. We're going to perform these calculations, and this is our output down below here. All right. And so this lists what we need for all of our output, what we need for our cleanup, and breaks our problem down into solvable steps. All right, so you should have read through that discussion forum. You should have performed this yourself before writing your code. I know for a fact most beginning programmers don't, and not that you can refine it to this level of detail. Your level of detail is probably somewhat larger, right, more general. But as you get into the general case, then you can begin to refine it, and you should refine that in your notes. Your notes become your comments in your code. Right, so we're going to stick then with these comments, and we're going to walk through the pseudocode and start solving the different parts of this problem. So our first thing we need to do is we need to get the input file name from the user, right? And we need to have a file to do that. And I gave you a couple of data sets to work with, but let's create our own file data to begin with, right? Let's go back and create a simple data file. So let's just go to File, New, File. And so one of our first choices here under General is a text file. So let's create a text file, open this up. And look, we're told that our file data is going to have the following in it. Now, I'm just going to put this in here for the time being. So the first thing we're going to do, we're told everything in here, right, is on the group size. It's on its own line. So let's just start off with a, let's just start off with a fairly simple group size of 10. All right, let's just start off with an asterisk count of 2. And let's say that our array size is, let's say it's 15. And then we're told that we have our data, right? So as we read things in, we're going to use the extraction operator. It's going to skip over leading white space, so we can leave a space in here. I believe I did in the file I gave you, right? You don't have to leave one. Let's just now put our array data in here. Right, and our array data should be numbers in the range of 0 to 255. We're going to have 15 of them. So let's put in our 0, no commas. Let's put in a 1. Let's put in a 255. Right, these could all be on the same line. They could be on different lines. Let's put in a 2. Let's put in a 3. So we had 5 numbers there. Let's throw in a 254. Actually, okay. Actually, you know what? I'm going to simplify this to start with. I'm just going to work with numbers in the range 0 through 9. So here's a 1. Now, I don't necessarily want it sorted. Here's a 3. Here's a 5. Here's a 9. Here's a 2, 7. Put in a 4. Let's put in another number 1. Let's put in 6. All right, so we've got 10 numbers. Let's throw in another 9. Let's run it 8. Put in another 3. Put in another 1 and another 0. All right, I just tried to randomly pick 15 numbers. Let's go with a group size of 3. All right, group size of 3, asterisk count of 1. This is the important one. This is the array size. Do I have 15? 0, 1, 2, 3, 4, 5. Yes, I have 15. All right, so we don't want this stuff in our data file. Now, leaving white space is okay. But let's save this. So let's file save text file 1 as. Now, what's important is that this go in your project. So here is that's my solution. So I've got a Visual Studio solution, and the solution and the project have the same name. So here in my project folder is, I'm just going to call this test dataset 1.txt. Right. So back over here in main now. So the name of my file is test dataset 1.txt. Back over here in main, the first thing we're supposed to do is we're supposed to get the input file name from the user. Let's handle that much. All right, so if we're to write all of this in main, I'm going to write some of this in main and then transition it to a function. So you'll hopefully see the transition to the function if you're having problems with that now. All right, we need to bring this in and store it in a string. That means here I need to include the string library. And so we're just going to call this input file name, right? And we want to prompt the user to enter that. So we're going to say stand. All right, that needs to be done on the console. So we'll give them a message that says enter input data file name. It would help if I had these going in the right direction. We need IO stream for this. All right, and we're going to read in that information and throw that into the input file name. All right. That's all it takes for us to get that information. Now I'm going to go way down here to the end and put in my return 0. Right? And let's build this. Right? Right. And I'm just going to right click and I'm going to say run to cursor. So we start this running. Right. You can see here our input file name is an empty string. That's what this means. Right. String is an object and it has some other values associated with it, a size, a capacity. The two double quotes together means this is an empty string, so it's initialized it to a blank string. So that's what the size means. How many characters are stored inside that string. Capacity means it is dynamically allocated, capacity of 15. The string class is very nice. If we enter something that's longer than 15, it will take care of that. We don't have to worry about it. So for right now, let's just view this much so we can see what we store in our string. Right. And so, like I said, we started this running. We've got the message. So our file is test-dataset1.txt. Now, I'm going to wish I had given it a smaller name. Oh, so sorry, I have to tell this line of code to execute, F10. So test-dataset1.txt. Our program will end at that point, right, because we read that in. Now, I really wanted to keep the debugger open so you could see that running. Let me do a run to cursor here. I want you to see that going into the string. All right, I'm just going to call this test.txt because I'm really not trying to open the file. All right, so now you can see here, this read this into the input file name. All right, so we've accomplished then that small goal. And when you work on programs, right, write these pieces and parts like I am, test them individually, know that you get them working. If you're having trouble with one part, go on and write another part, write some code to test that. All right, so like I said, you can see here that we have added the file name, right? We've added reading that in here. What if we wanted to do this from a function? In order to do this then, put this in a function, let's start creating some helper functions for our code and to create some other files. So I'm going to add another source file. So add new item, CPP file. I'm going to call this helper for lack of a better name. And I'm going to have a header file that goes with this. So I'm going to add that header file, add a new item. That is going to be helper.h. So remember the name of my h file is going to match my CPP file when they're related. And here we're going to put in the macro guard. So pound include helper underscore h included undefined. Remember, you don't have to. You can name the symbol whatever you want. We tend to use the name of the file underscore.h. You don't have to put included here. So pound, not include, pound if not defined. If not def, right? If not defined. So if the symbol is not defined, define the symbol, pound end if, right? And our prototypes are going to go in here. And then this is going to rely on this. So we're in helper.cpp. So we're going to include, right? We haven't written our prototype. Yeah, but helper.h. We're going to include that. Right here we want to, right? Here's our description. So we're going to read input file name. It's not much of a description. Let's write it. All right. So what we want to do in here is we want to do what we were doing here. We want to read in the file name and we want to return it. So we're going to, basically, right, prompt user to enter file name, read file name from keyboard, and then we can return the file name. All right, so if we're going to return the file name, we define that over here, this file name was a string. That means here, right, our return data type is going to be string. I'm going to call this read input file name. Now, does this require any arguments? No, it does not. It doesn't require anything else from main, which you don't see that already. You should see that as we write it. And let's just go ahead here. Let's copy this code right over here. Right. So since we're not passing this any parameter, right, here I'm going to declare this string and give it the same name. Right, we can then use cout to print out this information, use cin to read it in. Now, because we have not included the IOStream library here, and we're using functions from that library, right, we need to include that. All right, and so now that we've read this here, we can simply return input file name. Now, we've done other error checking with cin to see if cin happens to fail. Usually when it's reading a string, it will not fail. We could add some error checking here. For now, we're just going to keep this simple. If this actually fails to read in a string, one of the things that we can do when we get the information back is we can actually check to see if we have an empty string. Right? But for now, let's just write it like this. Like I said, most of the time, we're not going to fail to read in a string value. Right? So we're returning the input file name. Its data type is string. That's why our return type is string. We're not passing any sort of parameter to this because we're returning the string, right? And so back here, let's put in our function prototype. So in our header file now, let's add our function prototype. And there's our description. There's our return. All right. So back here in main, now if we want to use this function, we no longer need to do this part in main, do we? We can get rid of that. We still need the input file name. We need to declare it. And now I can assign to that input file name. We could call the function, right, read. Oh, and it's not showing up. It's not showing up because over here in main, we now have to include, right, the helper. So it goes in double quotes to look locally, helper.h. Now, once we do that and I type read input file name, IntelliSense pops that up, right? It doesn't require any arguments. We do this. All right. And so just as a little test back here, right, if we wanted to print out input file name to see that we're reading it in. We could also use the debugger to see that it's coming in, which is probably faster than typing this. But now let's run our program. So we've included this header file right over here. Then in the .cpp file, we defined our function. Over here, then we define the prototype. So let's build everything. And string is not a member. Oh. So here I have to include the string library. It's telling me the string's not a member of standard. Well, it's telling me that because I did not include the string library here. And I'm using that data type. So the header file doesn't know anything about it unless I include it. And right, it also, I don't believe I have to include it here now since it's included in the header file. Let's just go ahead and build everything again. All right, everything built nicely. So here I didn't have to include string. The reason being is here I had to include string because I'm actually using that data type. By including helper.h, which already includes string, I don't have to do so over here because in fact, I've already brought this knowledge of the string library in here. Right. And so let's start with that. Debugging test1.txt, right? That's not the name of our file. All I wanted to do was ensure that whatever I type in, right, is coming back to main and we're getting that input file name. All right. So now that we've got the input file name, we can go on to our next step of opening the input file. And so to open the input file, we're going to need, right, the IF stream class, and that then comes from the F stream. So we have to include F stream here. And I'm just going to call this infile. And so that would declare an object of type infile. Now, I can go ahead and call the infile constructor with my variable, which is input file name. This is what contains the name of my file. It will try to open the file. And then we're going to say, did the file open? So we'll say if infile dot is open. So you can check the is open. And basically we want to say, if that's not true, right? So is open returns true. So we could say, if that's not true, if it's not open, right, then we know that there was an error opening it. A shortcut is to just simply check the object state. So we can say, if not infile, right, which infile then has this overloaded operator, which, right, so see how I hover over that and this comes up and says bool standard IO space operator. You probably can't see that asterisk in that faint type, but this has this operator that basically tells us the state, right, of this object. So if the file failed to open, we can simply say, if not infile, right, I'm going to use the standard error stream and I'm going to say error opening file. And then we're going to print out the input file name. And then let's end the error message. Now, since our program is dependent on processing this file, if we can't open it, we really have no way to move on. All right, so let's see what we get now by running this, and let's use a file name that doesn't exist. All right, so, right, if my file name, so our file name was named test-dataset1.txt. So if I just type test1.txt, that does not exist in the directory, right? So we printed out the file name and you can see we got the message error opening test1.txt. Right, let's go ahead now and run this with our good file name, which is test-dataset1.txt. And we printed out the file name. Notice we didn't get an error message, so it must have successfully opened the file. All right, so one thing, right, when we're done with the file, we should close the file. Right. So right now, I am going to put that down here before the program ends. So my file stream object is named infile.close. Right, so I'm going to clean up by doing that. And that properly closes the file for us. All right, so now we've got the file open. We've got the input file name. We've got the file open. We want to start reading the file data. Right. And so we said our structure is we've got group size, asterisk count, and the array size here. Right. So read file data, group size, asterisk count, array size. All right, so how will we do that here in main? Well, we need some variables. All right, let's create a variable called group size, asterisk count, and array size. let's read these in from the file. Right? So we could simply do that with our file object in file. Right? Group size in file asterisk count in file array size. Right? We can do that. We may be tempted to read these in all at once. Right? That can be done. I prefer not to do that because I'm going to check to see when this fails. Right? Now, the test data I gave you should not fail. That doesn't guarantee that your file will not fail. Let's go back to what the assignment said. The assignment said something about you may assume the group size asterisk per count and total number of elements in the data set will all be positive non-zero integers. Right? So we don't have to check to see if those are positive non-zero integers, but we want to make sure that we didn't fail to read anything. I didn't put garbage in the file, but we want to make sure there wasn't some sort of non-numeric garbage in the file. So let's read this. So as is, right, with our file, let's print out. So let's print out. Actually, let's not print out because that takes more time. Let's actually walk through this. So start without, no, sorry. I have the debugger running. Let me right click, right, run the cursor. So we'll build this new code. All right. And so this is popping up and it's asking me for the data file name. So this is test data set 1.txt. All right, so it successfully opened our file. We're waiting to execute this line of code, right? We have garbage in group size, asterisk count, array size, as we can see down here. Right, I hit F10. Right, now I have a 3 in group size. Well, back to our file, there's the number 3. So we expect to read 3, 1, and 15. Right, F10. So now asterisk count has a 1, array size has a 15. So all those successfully read in. Right, we had good values here. But what happens if we have some garbage in our file? Like, I didn't mean to say that. Sorry. I do want to say that. Yes, let me overwrite the same data set. Yes. I can't access the file because my program's already holding it open. Stop the debugger. See, important to close the file. Now I can save that. All right, so now I've got this garbage in here, meaning if we walk through main, right, so let's run the cursor. We should, so test data set 1.txt and F10. All right, so you can see that group size, we read the 3, but this is going to fail. Asterisk count, right? It failed to read, so it just stored a 0 in here. And array size will fail to read as well because we're actually in a fail state. You can see it didn't even try to read array size. It tried to read asterisk count, but then it went to a fail state, and so it wasn't even able to execute this statement. So we want to do some error checking. So let's stop this. And let's say if, right, in file dot fail, right, we're going to print out an error message, error reading group size. If we can't finish reading this, right? If we don't want to read this, we basically would want to leave main, right? We'd want to return. Similarly here, we want to check for asterisk count. So our error message is a little bit different. And same way here for array size. If we fail to do that, we want to print that out. All right, so let's walk through this. Run the cursor. All right, now I'm going to hard code this name in so I don't have to keep typing it. All right, opened up our file, it opened it up. Now it was able to read group size. So remember we've got over here, we've got the 3A. So it should be able to read group size. After 10 now, that's good. But now when we try to read this, it fails to read something. It stores a 0 and asterisk count, and this should be true. Right, we'll print out this error message. Right, pop up the console, we get the error message. And in this case, then the next statement will cause this program to end. Right. So we've got then that error checking. We don't want to go on without that. Now, all right, here I don't want to keep typing in my file name. And so for the time being, I'm just going to hard code in my test file to make my testing process faster. Test data set1.txt. And all right. So I'm just doing that. Right, so now that we can work with this, right? And actually, if I did a start without debugging, just to test that I didn't break anything there, right? We got our message error reading asterisk count, which we expect to get. All right, so we've got a lot of code going in main. We don't want all of this code. It was fine calling this function, right? This little bit on checking to see if this opened correctly. This is fine. Right, but now this is getting a little bit messy, right? Different ways we could handle this. I mean, we could write a function that says, okay, read group size, read asterisk count, read array size. I'm going to write a function that actually handles reading all three of these. So what I'd like to do is I'd like to take this code from main, pull it out of main. I want to go over here to helper. Actually, I want to write a function eventually, but I want to put this code inside. If I'm asking this code to read three separate things, that means I need to send all of this data back to main, right? Main is going to need access to group size, asterisk count, and array size. No, it doesn't make sense to put it in array because these are all three different variables. They have different meanings. So in order to follow good programming practices, we want names that have meaning, and putting these in an array really doesn't have much meaning. Right? Now I'm going to call this actually let's do this in two different ways. Let's do it in one way. I'm going to okay, I think I called mine read file, read control data. Right. So this controlled the way my program behaves, so I happen to call my function read control data. All right, I want to read group size, which is an integer, so I'm going to have a reference to group size. I'm going to have an integer reference to asterisk count. And I'm going to have an integer reference to array size. This is also going to need this stream operator, right? This stream operator type, if you go back in main, is standard if stream. We want a reference to it so we can access it. We don't want a copy of it because whatever happens to this, we want that state to be known back in main. So we want a reference, not a copy. Now, notice when we were in main, we were just leaving. So we could call exit, right, and exit the program. What I'm going to choose to do is I am going to return a Boolean type. And what this function is going to do is if it fails to read something, it's going to return false. If it correctly reads all three of these, then it will return true. So for any of these error conditions, if any of these occur, it's going to return false. If it gets through all of these to the end, that means it read all three, so we'll return true. All right. All right, so our parameters, all right, input is in file, right? File, stream, sorry, input parameters. So let me just call this input parameters. In file, read from this input file stream. Or it should be, sorry, this is an input file stream. Our description is reads data from input file stream. Stores data successfully read in the corresponding variable, returns. Sorry, talk about the return in a second. Okay. Output parameter, right? Group size, right? Group size data read from in file stream. Asterisk count. All right. Now the name, this is kind of redundant, asterisk count. Data read from in file stream. Some of this is redundant. You don't need to necessarily have this much, but I want to be very explicit, right? In these comments, you should write your comments for you. You're the one that has to go back at your look at your code. Now, when the TA grades or I help you, we have to look at your code as well too. Now, write your comments in a way to make this understandable. Write your comments in a way when you go back and go over this to study for the exam or to rewrite this code in practice, you know what you were doing. All right, so, and this is array size data read from in file string. Okay, so return value returns true when group size, asterisk count, and array size are all successfully read. Returns false if any, returns false when any of the, it returns false when it fails to read data from the input string. All right, so there's a description of what our function's doing. Let's put this over in the H file. All right. So here's some comments to the user about how to use this. All right. We could add a description here as well. reads input file name from the keyboard and returns the string entered, right? Maybe not the best description. All right, so now we've got our prototypes here in this file. We've got this here. Let's go ahead and save everything. Now, back in main, let's call this function. Right. And in order to call the function, I'm going to say, I can call the function, then I call this read control data. It's expecting in order a reference to group size, so I just type the group size variable, asterisk count, right? I use the names here in main. Now I happen to use the same name as the array parameter name, so that makes it a little bit easier. And now it's expecting a reference to the file object. Well, our file object here, I also happen to use the same name in file, so we pass that. Right. This then would cause this to read the data stored in group size, asterisk count, and array size. Now what I might do as well is I'm going to say if, right, if this returns false, right, then error reading control data, right, program terminating. And now from main, I can simply leave. Before I leave, I actually have the file open, so we should probably just go ahead and close the file, right? Because once we leave, we'll never execute this line of code down below. All right. So this returns true if everything's read, returns false if it can't read any one of these, and we'll execute this code. So let's see if I can do a run to cursor if everything builds. And no. In file does not find this up. Oh, I haven't included that, nor have I included that here. So here in the header file, right, I need to include fstring because we've got an object of that type. Clean out the old stuff. Let's build this. Yes, that took care of all of that, right? All right, sometimes you get a lot of error messages when you fail to include a library. All right, so let's then run to cursor. Right. All right, let's step into this function. So F11 then will step into read control data. Right. You can see here locally, right, we haven't read anything in yet. We've got this pointer back to in file, pointer back to our file stream. So I'm going to hit F10. You can see that we've read in group size. Now remember, this should fail then when it tries to read an asterisk count because we've still got that value A over in our file. Right, it failed to read that, it put a 0 in, so now we're going to get out this error message, we're going to return false, right? We'll go back to main, this will be false, so we'll print this out, we'll close our file, and our program will end. If I hit that last one, you can see then I popped up the console that we're getting these error messages. All right, so that's one way to check then, to make sure that our program is handling everything as we want, is simply by, in this case, we corrupted the file. Now we can try corrupting the file in other places too, right? If I corrupted there, when we come back from reading array size, we won't have actually read this yet, and that will corrupt something later. So let's not do that. Let's just go back to our good case scenario, right? In our good case scenario, then back in main, when we get down here, right, we should actually then have data in our file. So let's just say, actually, I can do a run to cursor to this point in the code. Actually, it's going to run the whole thing because unless I have code there, it will just actually run down below. You can see that we just got this popping up. Let's stop that. Let's run the code down to here so we can see what's in group size. All right, so you can see all that code ran above, right? We cleaned out our data file so that it would work as expected, and we've got all of this information in here. All right, so I'm going to stop the debugger. All right, so we wrote a file, or we wrote a function then that had 3 reference parameters. All right, we were able to read this data into variables that the names make sense. We could have written something differently over here. Notice then this code looks a lot alike. So instead, if we wanted to, we could write some function here. I'm going to still return true and false when this fails to read. I'm going to say, if I said something like read integer value, because look, each one of these is trying to read an integer value, isn't it? So read integer value. And here, then it's going to need the file stream to read from. I'm going to call it in file again. All right, sometimes people just call it in to shorten up what you need to do. Now I need some sort of integer, actually. Here I need some sort of integer value, a reference. So I can say standard, oh, not standard. I can say int reference value for my integer value. So I don't have to declare that. And then basically I just say in file, read in the value. And then I can say if in file dot fail, right? If that's true, then same thing, standard error, see error string. We could say error reading integer value from file. Error reading integer value. Function. You can print out the function name if you want with a double underscore, lowercase. If you want to know what function that occurred in, I have to add that. And then we're going to return false. Right. This is what we're doing in common. Basically, we're taking this section of code, putting it into its own function. Otherwise, we'll return true. And we could write our code this way. Now we need our function prototype. So let's throw that in here. All right. Eventually, we should add some good comments. I'm just showing you different ways. So now in main, instead of doing this, right, we could do this. We could say read integer value. We can give it group size. We can give it in file string. And we can say if read integer value, right, equals false. So if we had trouble reading that, then we could say something like standard C error. Error reading, this time we were trying to read group size. Program terminating. We'll close our file. We do that here in main, and we can simply terminate here in main. And then we would need to do that, right, for asterisk count. We could do that. And we could do the same thing for array size. Save that, right? We could go back. We could corrupt the data there so it fails to read group size. We can run this, start with that. And I had a bill there. What was my bill there? Yep, semicolon. Run this. All right, so we introduced an error where we expected it to fail reading group size. That happened. All right. So you do want to test, right, all of your code. We could create an error that fails to read this. This would come up and tell us it failed to read the asterisk count. We can create an error that fails to read this. This tells us it had trouble reading the array size. And then we run the test condition, right, of everything's good. And in this case, it runs, right, and there's nothing for it to display. All right, so you want to test. You want to test these different conditions. All right, so I showed you a couple different ways of writing this, right? We did the function that took all three variables. We did a function that just read one at a time. So we actually had to add this particular code in here. We could write that function in a slightly different way. So what if we write the function and call this? So what if this returns the integer value? And what if, again, if I overload this function and call it read integer value? And what if we just pass it the file stream object? And now, because we're going to read, we're going to have to locally declare an integer value because it's not, see here it was in our parameter list as a reference. Here we don't have it in our parameter list, so we have to declare it locally. We're still going to do this. Now, if we do something like this, this looks very much like what we did. So if I save this, put in that prototype here, and if we were to go back to main, that's going to look a lot like what we originally did in main, where now we would try to say group size. We're going to call read integer value. We're just going to pass it this file stream operator. And now we don't have any way of knowing whether this failed. So here we have to say if infile.fail, blah, 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 standard C error. Oops, error, failed to read group size. All right, we could do that. We would close our file. And then we return. All right, so what if we did this much? Let's see if I can build this now. All right, so it's complaining that I've not used asterisk counter array size. Read integer value must return a value. Yes, I forgot to do that. Duh. We need to return the value, don't we? Silly me. All right, now that built. All right, let's introduce that error here before group size. Let's say start without debugging. Right, we get that failed to read group size. Or if we get rid of the error, it should read the group size and we won't get any output. Right, we don't get any output. So back to main, that's you know, if you look at what you just did here, it's likely is not, this particular function really isn't worth writing, because you could have just had that statement there in main and checked to see if in file failed. So I would say this would not be a good function to write. There are ways of actually returning the in-file stream, and then you have to actually have this as a reference. Instead of returning bool, we could return the stream back. Like I said, there's many different ways to do this in C++. Let's get rid of this function. It wasn't a good one to write. I wanted to show you that, yes, you could write it, but it looked pretty much like just writing all of the code in main, right? It was only reading, basically using that one line of code that we could have written in main, very simply. All right, so let's go back to where we were, and then back in main, this went away. So let's get rid of this. All right, I showed you that. Like I said, you can keep either one of these solutions. I happen to like this solution in main that took care of all three of these for me. I felt that they were all related in some way, right? I know that every file is guaranteed to have the information like this. So this actually then filled out my group size, my asterisk count, my array size. Here was our code if we wanted to do the other. I'm going to get this out of my example now. And so now we're back to where we should be able to read all of this in. And once we read this in, we can dynamically allocate the array, which we will do in the next part of this video. I'm sure this video has gotten way too long by now. So let's save that. Let's rebuild, make sure it builds correctly. Right. If we were to run this again, we would actually not get any output. We'd have our values stored here in group size, asterisk count, and array size. All right, so like I said, I'm going to end this. When we come back, we will dynamically allocate our array in part 2.